this video, we will only be covering page 1, the 6 graphing problems. On page 2, you will find factoring problems. We've done factoring problems this week. We did some during the second and third 9 weeks, and I know that you did factoring during algebra 1. So those 6 problems on page 2 and the lesson 5.1 homework assignment are all due on Tuesday of next week. At this point, we have not covered every technique for factoring or every technique for vertex form or standard form. So please understand, when matching these, it might require us to use a guess and test. So I would suggest looking for some of those common points that we've discussed that would lead us to an equation. For example, in problem B, we have a vertex at -1, 5. Because this number is negative, keep in mind when I stick that into the equation, it's going to become an addition problem because x minus -1 will actually be x plus 1. So I'm looking for an x plus 1 and a plus 5. And in the 3 equations, that doesn't exist. If I will look at graph A, there is a vertex at 4, 2. Because this is positive, it's going to be x minus 4 quantity squared plus the 2. And that's the second equation. So this second equation appears to be A. If I go over 1, I'm definitely going down, and the A value is negative, so the graph is flipped over. And it appears that it's going down about half a unit, which is the fractional part of the equation. So the second equation definitely looks like the answer is A. For equation C, we are definitely going through -1 and through 2. The vertex is a little unknown to us. There's an integer value. Because it's going through -1, that means the factor is going to be x plus 1. Because if I stick -1 into x plus 1, it makes a 0. And these values on the x-axis are called the zeros. And the second one is going to be x minus 2. Because if I stick 2 into x minus 2, it makes a 0. So equation at the top has those 2 factors. We have the x minus 2 and the x plus 1. So the top equation appears to be C. The A value is 2, and that's a little hard to describe because we're not necessarily know where we're starting at. But if I go over 1 and I go up, again, it's really hard to know whether or not we have a value, a correct A value there. But we definitely have the right factors, x minus 2 and x plus 1. Back to equation B. Sometimes if you don't have enough information, if we do have a vertex, but we don't necessarily know where the graph crosses the x-axis, we can take the vertex and stick it into the equation and see if it actually works. Kind of the checkpoint. So wherever x shows up at, I'm going to replace it with a -1, and then it's supposed to equal 5. So -1 squared is 1. A -4 times a -1 is a +4, plus the 3. -2 times 1 is -2, plus the 4, plus the 3. -4 plus, -2 plus the 4, that's a 2, and 2 plus 3 makes 5. So this does work. So the bottom equation here goes with graph B. We can use the vertex as kind of a way of supporting the equation works. So in the second part of page 1, graph A definitely is intersecting at -1, -2. So because of the -1, if I'm putting the equation in vertex form, it's going to be x minus -1 or become x plus 1. And if I look over here, I don't see an x plus 1. We don't have integer values where the graph crosses the x-axis, so we don't necessarily know the zeros. In graph B, it definitely intersects at 2 and 5, so that means the first 0 would have the expression x minus 2, because 2 minus 2 is 0. And the second factor would be x minus 5, because I stick in 5, which is the 0. 5 minus 5 makes a 0. And that lines up with equation B. In the third graph, here's we're going through -4, -1. So I'm looking for an x minus -4 or x plus 4 squared minus 1. And that looks like that's the top equation. If the graph is definitely going down, that's the negative value. And if I go to the right, and if I go down, it looks like we are over halfway. So I'm looking for a fraction that's going to be a little bit more than a half. And 2/3 is like 0.66. Repeating, it's definitely more than half, which is 0.5. On the third equation, I'm going to substitute in the vertex and show that the third equation at least works for, the vertex actually works for the third equation. So the answer is going to be -2. We have -1 squared plus 2 times -1 minus 1. So -1 squared is 1. That's -1 times -1. 2 times -1 is -2 minus 1. 1 minus 2 is -1 minus 1. And -1 minus 1 is -2. So the third equation, even though we don't have its vertex form or factored form, the third equation A does match up, or the third equation does match up with graph A. So continue on to page 2 using the factoring techniques. Again, those problems will be graded on Tuesday, and then the homework assignment 5.1 will also be graded on Tuesday.